Yes, sir.
Take down the question. A small planet is revolving. Do one thing. Yeah, you have to give me the a time period in proportional to radius. How much will it be? So where a small planet is revolving around another large planet, what is happening? What are the forces on them?
So centripetal force and the force GM.
So now what he says is, if the gravitational force between the planet and the star is proportional to r power 5 by 2, that means mv squared by r will also be proportional to r power 5 by 2. Yes. So the gravitational force if the gravitational force is proportional to r power 5 by 2, then I will say mv square by r is also proportional to r power 5 by 2.
Yes, sir.
Yes, sir.
Right? So I am removing this proportionality. So it will become mv square by r is equal to some constant into r pi by 2. So from this, get me your v.
Sir, I have a doubt. Why can't we use t square as proportional to r cube formula?
Please change it to minus 5.
Minus.
R power minus 5 by 2.
Excuse me.
Yes.
Sir, they have given if the gravitational force between the planet is proportional, sir. We have taken centripetal force, no, sir.
That's what gravitational force is
Yeah,
equal to
mm by
your
r.
centripetal force, then only the planet will be revolving. No?
Oh, yes, sir. Yes, sir.
So if your gravitational force is proportional to your radius power minus 5 by 2, so will your centripetal force also. No?
Yes, sir.
So t square is proportional to r cube formula for this.
You cannot use there because here it is changing it as r power minus 5 by 2.
So is V directly proportional to R power minus 3 by 4?
Minus 3 by t you are telling.
No, V.
We take this r that side.
R power
Minus 3
minus
by
3.
2. So
Square also
k
comes as
r power minus 3 by 2 divided by m will be equal to your velocity, right?
so R will become minus 3 by 4.
No, just keep because he's asking time period. No, we know time period will be equal to 2 pi by omega is v by r.
Yes, sir.
So 2 pi r divided by v. What is your v from this? Substitute here. Get me your this. Substitute your v in this. This v substitute here. It will be 2 pi root m r divided by root k r power minus 3 by 2. Minus 3 by 4 it will become, it will go up 1 plus 3 by 4, 7 by 4. Huh?
So
Correct?
V is directly proportional to R power 7 by 4.
Now you understood why I have used my mv square by r.
Sir, by using gravitational force formula, we can't get the answer, sir.
How do you get by
if-
using your gravitational force formula?
No, sir. As gravitation force is inversely proportional, so we can use F is inversely proportional to 1 by R power 5 by 2.
Gravitational force Fg is directly proportional to r power minus 5 by 2. Gmm divided by r square is directly proportional to r power minus 5 by 2. So Gmm is directly proportional to r power. This goes to that side. How much is it? Minus 1 by 2.
Yes, sir.
Minus 1.
How do you get your time period?
Yes, sir.
Understood?
Yes, sir.
That's the reason why I have taken my mv square by r. But my time period is 2 pi by omega. Omega I can write it as v by r. So I can get my v by r from this. So v I get substitute time. Clear?
Yes, sir.
A planet revolves. A planet revolves around the Sun in an elliptical orbit of semi-major axis 2 into 10 power 12 meters. The aerial velocity of the planet when it is nearest to the Sun is 4.4 into 10 power 6 meters square per second. The least distance between planet and the Sun is 1.8 into 10 power 12 meters. The minimum speed of the planet in kilometers per second is
Sir, is the least distance 1.8 into 10 power 12 only?
Is it?
Is the least distance correct?
Your voice is breaking.
Nothing, sir.
What do you mean by aerial velocity?
dA by dt.
Correct. I gave you the formula for this, right?
Yes, sir.
What is the formula?
dA by dt is equal to L bar divided by 2m.
Huh?
L bar divided by 2m.
Half r square omega. See, I don't know if you have remembered it or not. This is your r. This is your d theta. If it is very close, this becomes like a triangle. So I said my area is half base into height.
Yes, sir.
Half base is r, height is r d theta, no? Half r squared d theta is your area. Differentiating both sides with respect to time,
Half
d
r
theta by dt is
omega.
Omega.
Right? If you forget also how Kepler's law. So shall I go forward now? Let's solve it. Okay. Now see this this R here it is if it has radius, but now if your it is in a planet revolves around your sun, so probably your sun will be something like this and your planets will be revolving something like this, right?
Yes, sir.
So from here to here, the total distance, if I
2
take
into
it as
10
2
power 12.
times of my r, from here to here it will be smaller, right?
Yes, sir.
Is distance between the planet and the sun, so small r is given. The minimum speed of the planet will be, so minimum speed, where will it be? Apogee. So here you have to find your speed of your planet at this point. So this is your sun. This is your perigee distance. Total distance is 2r. So hence this distance will be 2r minus r. And I need my velocity at, or the minimum speed at your apogee A.
Sir, 2r minus r is 0.2 into 10 power 12 meters. That is in the minimum distance.
Yeah, we'll try to do it. So this I will take it as half 2r minus r whole square into omega.
Omega.
right?
Yes, sir.
So be half 2r minus r, 2r minus r into omega. This term which is there, this can I take it as velocity at A?
Yes, sir.
R omega is your velocity,
Yes,
no?
sir.
So from this, it is half 2r minus r into VA will be equal to your aerial velocity. And
Yes,
the
Yes,
sir.
sir.
aerial velocity is AB, right?
Yes, sir.
So from this, velocity of A is 2 times the aerial velocity of A divided by 2r
2r minus r.
minus r. Understood?
So is it 40 kilometers per second?
Huh?
40 kilometers per second.
Just per second, yes. Understood the concept?
Yes, sir.
Shall we go to the next question?
Sir, 2r is the semi-major axis or only r is the semi-major axis?
Next question. Somebody asked a question.
Yeah, so the 2r over here, the whole 2r is a semi-major axis or only r is the semi-major axis?
See, R is your semi-major axis.
Okay, r is a semi-major.
Huh. From the,
Center.
generally we say focus to focus, but focus will be very close to either end. So that's why we'll take it as a this one. Okay. But from the center of the ellipse to the end point, we call it a semi-major axis. From the center to this, we call it a semi-minor axis.
Okay, sir.
You didn't complete ellipses, ellipse, circle.
We didn't do, sir.
No, sir.
Please go for conservation of angular momentum and conservation of linear momentum. Understood? Hello?
Yes.
It has a ratio of speed set up over and energy. So whenever these kind of questions are given, conservation of angular momentum and conservation of energy at very easy. What is the conservation of angular momentum? L very easy equal to L opposite. So M V very easy, radius very easy equal to M V opposite, radius opposite. It's a cancel. So So let's leave it like that. So V very radius very easy is equal to V opposite. Let them be your equation. One. Oh wait. Angle is given no. Cos inverse angle is given no. Yes. Yeah. And then what is it? Tangents are negative no. Yes. Even when it is suddenly changed, this should also be equal to M. Some B, some radius. B by B cos theta. Right. Yes. This also cos theta is 3 by 4. So B radius is equal to V opposite is equal to velocity into radius into velocity 5. Right. Understood? Let's do equation 1. Now consider and conservation of energy. Take the opposite and take the theta position. Okay. You can conserve your energy at opposite and theta from the direct by relation of opposite and velocity. So I will get my some relation you use and I get this relation. Understood? Understood? Hello?
Yes, sir.
So your total energy at the opposite, tell me. Half M V square minus E M divided by R A is equal to minus G M divided by R plus half M E square. Right? Yes. So let's cancel. Let's go. Do one thing. Get me an equation. This is V square by 2. So this comes here. equation?
Of A square minus V square is equal to GM into 1 by RA minus 1 by R.
You will get a quadratic equation. No? Yeah. Yes. See, VA is VR by 5 RA, no, from here.
Yes, sir.
Hmm. So change everything into V's. Change the whole equation, change it to V naught, V and R. So I'm multiplying with 2 VA square minus 2GM
Into 1 by R
by RA minus 1 by R
is equals to V square.
minus V square is equal to 0, right?
Yes, sir.
So V is 9 V square
R square
R square divided by 25
RA square.
minus 2GM. R I'll take it, okay, I'll take it as R common. It will be R by RA minus 1 minus V square is equal to 0, isn't it?
Yes, sir.
If that would have been just R, then yeah, I could have been easily solved it. Mm, I put into R divided by R, this becomes GR into RA by. So I'll get my substitute G. Okay. Um, See, here I want to change it into something. So if I can change this into something, then I'll, if R square by R by RA, if it is there also not a, this is just a potential. Yes, GM by R is a potential. It's a relation between potential and everything. So into R and by R it will be. See, this I will write as 9V square R square divided by 25 RA square minus 2GR into R by RA minus 1 minus V square is equal to 0.
Yes, sir.
Everything should be in terms of this one. This excess R I am getting. This I have to remove it. If I can remove that, everything is what I will take is R by RA to be some X, then I'll get this as 9 by 25
E
X
square into
square
X.
B square minus 2GR into X minus 1 minus V square is equal to 0. It will be a quadratic equation, right?
Yes, sir.
But we have V's, so I'll take VR by this one. If I take it, then I'll get it as a quadratic equation, then this I'll get. Okay, leave this. I'll try to solve this and I'll send you the solution. Okay.
Okay, sir.
Difficult solution. This is how your gravitation questions will be. Okay.
Yes, sir.
Check if we have done this question. The mass and diameter is 3 times of the respective values for the Earth. If the time period of oscillation of a simple pendulum on Earth is 2 seconds, then the time period of oscillation of simple pendulum on the surface of the given planet is.
No, sir, we didn't
No,
do.
sir.
Take down the mass and diameter of a planet. The mass and diameter of a planet mass and diameter of a planet are three times of the respective values of Earth. Are 3 times of the respective values for the Earth. Full stop. If the time period of oscillation, if the time period of oscillation of a simple pendulum on Earth is seconds, if the time period of oscillation of a simple pendulum on Earth is 2 seconds, then the period of oscillation of the same pendulum, then the period of oscillation of the same pendulum on the surface of the given planet would be, on the surface of the given planet would be.
Sir, on Earth is 2 seconds, then the
Can anybody repeat the question?
Then the period of oscillation of the same pendulum on surface of the given planet would be.
thank you.
So T2 is equals to root 3 2.
Huh?
T2 is equals to 2 root 3.
Calculate your acceleration due to gravity, right? Get
Yes,
a relation between acceleration due to gravity on Earth to acceleration due to gravity on
on the
the
planet.
planet. Because
M
G
by R
of the
squared.
Earth divided
R
by
squared.
R E of the Earth,
And
G
G
of
of
the
the planet
planet
is
is G
G M E
mass
into.
of the planet divided by 3 times.
Yes, sir. Both of them are 3 times. So it will be G M E into 3 divided by R
So
T squared.
1/3 of GE.
Yes, sir.
So T is directly proportional
Divided
to
by
under
root 3.
root G. T2 is T1 times
Root 3.
1 divided by GP. The GE 3 goes up, root 3 T1, 0, 2 root 3 seconds. I think this way of understanding, body on the surface, if it is attached to a string, the elongation is this much. If it goes to a height, then the elongation is.
We have done.
The gravitational field in a region is given by the gravitational field in a region is given by five I cap plus 12 J cap. 5 plus 12 J cap. Full stop. The change in gravitational potential energy, the change in gravitational potential energy, if the body is taken from origin, if the body is taken from origin to a point, to a point 7 comma minus 3.
Sir, can you once repeat from starting?
Take mass as 2 kg. The gravitational field in a region is given by 5 I cap plus 12 J cap. The change in gravitational potential energy when it is taken from origin to 7 comma minus 3 is.
Sir, I hear some static noise. Is it for me or is it for everyone?
I don't know.
Okay, maybe me, sir.
Have you taken down the question?
Yes, sir.
Okay, do it.
Is it minus 2 joules?
Plus 2 joules.
So even I got minus 2.
Let me solve it. Yeah, okay. I'm thinking about a question which we have left it, not a calculation. I'm just trying to do it. I got it. I'll tell you. This question, yes, come here. What will be your potential delta V formula?
So integration x.
Yeah, minus E dot dr. Delta V, I'm not asking V, right?
Yes.
Understood? If I'm asking V, that will be minus integral E dot dr.
Okay,
This
sir.
is nothing but your position vector, right? Which is R2 minus R1. Is it 7 minus 0 is 7 I cap
Minus 3 j cap.
minus 3 J cap, right?
Yes, sir.
So this is a dot product. Gravitational field strength is given minus 5 I cap plus 12 J cap dot 7 I cap minus, how much you'll get?
35 minus 36 minus
Minus 1, right? So 1 joule. No, 1 joule. This is Newton per kg. In its change in potential energy, no? So it
Yes,
is
sir.
delta V into
M.
M. So this is 2 joules.
1.
Correct? Mass is given as 2 kgs, no?
Yes, sir.
Two concentric, two concentric two concentric spherical shells of masses m1 and m2 r2 are as shown. Two concentric spherical shells. The gravitational field strength at point P is gravitational field strength at point P is
M1 by R square.
G
Minus G M1 by R square.
See, I say it is constant spherical shell, right?
Yes, sir.
For the shell inside, what is your field?
0.
So for this shell, the point is in will be
0.
For this shell M1, the point is outside. So for this it will be
Minus G M by R square.
y minus gravitation efficient y will be minus. We will mention minus only when the asymptote will be just one. Shall I go to the next one?
Yes, sir.
Gravitational acceleration on the surface of a planet. Gravitational acceleration on the surface of a planet. Gravitational acceleration on the surface of a planet is root 6 by 11 g. Is root 6 by 11 g. The average mass density of the planet is the average mass density of the planet is average mass density of the planet is 2 by 3 times that of Earth is 2 by 3 times that of Earth. The escape velocity for the planet is the escape velocity of the planet is what is the escape velocity on Earth?
11.2 kilometers per second.
What is the escape velocity of this planet?
You need to find the escape velocity of the planet.
Okay.
Mass density of the planet is given, no?
Yes, sir.
2 by 3 times.
Mass density of the Earth.
So from that, what can you get? Get a relation only. Don't get your this thing. How much?
The mass is
Why mass will be same, Mama? See, what is your G formula? Gm by r square. So this will be G by r square into 4/3 pi r
Yes,
cube
thank you.
into density, no?
Yes,
So from this you say your G is directly proportional to
R. Yes, sir.
we know your escape velocity is
Root 2
2
GR.
GR.
right.
Yes, sir.
Next step is directly proportional to under root G into R.
So we is R root rho.
From here, R is G by rho. This R is G by rho. No?
Yes, sir.
So your escape velocity is directly proportional to G
By
divided by under root rho, isn't it?
yes, sir.
Correct?
Yes, sir.
So now V of the planet divided by V of the Earth is equal to Gp of the planet divided by G on the Earth into rho of the Earth divided by rho of the planet.
Yes, sir.
So is the answer
How much?
3, sir.
Escape velocity of the planet is 3 kilometers per second. Weight of a body, weight of a body, weight of a body of mass m, of mass m, decreases by 1%, decreases by 1% when it is raised to a height h. When it is raised to a height h, when it is raised to a height h, Earth's surface, from the Earth's surface, full stop. If the body is taken to a depth h, if a body is taken to a depth h, change in its weight will be, change in its weight will
So 0.5%.
height and depth, no?
Sir, I got 0.5%, sir.
Yeah, 0.5% decrement, right?
Yes, sir.
No, G dash is equal to G into 1 minus 2h by R. If it is going above, right?
Yes, sir.
Hmm. Hmm. Weight decreased by
1%.
1%. So M into M, if I take, this will become 99 by 100 of weight. Right?
Yes, sir.
Weight into 1 minus 2h by
R.
R. W 1 by 100, 0.02. So h is equal to 0.005 times the radius. Right? Now, if it's going to a depth, this is height. Depth again, g into 1 minus d by r. But d itself is the same height h, no? Correct.
Yes, sir.
So m multiplied, right? So this total will become delta w by w will be equal to how much? 0.5 0.995.
Yes.
No, 0.995. Correctly. No, we do one thing. First, tell me what is your W dash by W? 1 minus D divided by R. D is 0.05 R. So this is 0. Now minus 1 both sides, right? So it will be 0.005, that is 0.5% decrement. Good. A body is projected with a velocity of a body is projected with a velocity of a body is projected with a velocity of 44.8 kilometers per second, 44.8 kilometers per second from this Earth's surface. From the Earth's surface. The velocity of the body when it escapes from the gravitational pull of the Earth. The velocity of the body when it escapes the gravitational the velocity of the body when it escapes from the gravitational pull of the Earth will be
It's 43.3 kilometers per second.
44.8 kilometers.
43.3 kilometers per second.
Root 15 V, no?
Sorry, sir.
When I got root 3 into 11.2.
Why you will get root 3 into 11.2?
So 11.2 is the escape
The
velocity.
velocity with which it goes is V square minus VE square, no?
Yes, sir.
So 44.8 means 4 times of escape velocity, no? So 16 VE square minus VE square, no? So root 15 VE, right? Yeah? What is it?
No, like if you calculate, then we'll get 43.3 only.
That's okay. This is the way, right?
That's how I did, sir.
Okay. The period of revolution of planet A, the period of revolution of planet A around the sun is 8 times that of B. Is 8 times that of B. Full stop. How many times is the distance of A from the sun? How many times is the distance of A from the sun greater than that of B? Greater than that of B.
Four times, sir.
4 times.
4 times, sir.
How many times is the distance of A from the sun greater than that of B? No,
8 times. 4 times.
from the sun. How much? No, it will be 3 times. No, you will get 4 times. Say this distance of A will be 4 times of distance of B. No,
Yes, sir.
of A is 4 times of distance of B. Is asking how many times is the distance of A from the sun greater than this of B.
Yeah, so it's 3 times.
So it's
Understood? You directly use
Yes.
this t square is directly proportional
To R.
to r cube. Okay. Do this question.
So 4 by 3 GM.
One. He's asking the magnitude of gravitational force at origin. Huh?
Yes, sir.
So 1 by 4, 1 by 6,
Right.
it's in a GP.
Yes, sir.
4/3
So
GM.
1 by 1 minus 4
It's
by
4 by 3
3
GM.
by 4, 4 by 3. So yeah, it is.
4 by 3 GM.
Hmm.
So we have already done this question.
So we've already done it. Okay.
Yeah.
This question.
So this also we did. Answer is D by 3. Yes, sir. This one we did.
The torque on a planet about the center of sun is how much? 0, negative, positive, depends on the mass. The torque on a planet about the center of sun.
You're telling the question,
Is
sir.
it 0? The torque on a planet, the torque on a planet about the center of sun is.
0.
Why?
Because all the forces are acting on the sun. The distance becomes 0.
The forces which are acting are equal in magnitude, so they get cancelled.
No, sir, the R dot is R bar cross F bar, and R is always the center.
Theta is going from 0 to 180, again 180 to 0. So sine 0 is?
0.
Sine 180 is?
0.
So that's why your torque acting will be 0. If the radius of Earth shrinks by 1.5%, if the radius of Earth shrinks by 1.5%, then the acceleration due to gravity changes by, then the acceleration due to gravity changes by.
So does it increase by 2.25%?
Hmm?
2.25%.
It increases by
2.25.
2 point. Why you got 2.2? It should be a whole number, Amma. Why it cannot be
2%.
2 and all that. Huh?
2%.
2%, huh?
Yes, sir.
No. See, your G dash is equal to G by R plus H the whole square, right?
Sir, 3%, sir.
Right. So I am saying it is shrinking, no?
Yes, sir.
So H, which is it, is shrinking by some 1%. So you can change this as R plus some delta R whole square. So take it up, go for your binomial expansion. G by G will be equal to minus 2 delta R by R. This is how much?
1%. 1.5%.
It is reducing, so minus into minus is understood.
Yes, sir.
Do the whole thing for you.
Yes, sir.
No, what I'm asking is, should I do the whole question for you, or is it sufficient?
So can you please solve, sir?
You want me to solve it?
Yes, sir.
Your G is equal to Gm by R square, isn't it?
Yes.
Right?
Yes.
So G dash, if I'm just if I'm taking the radius changes by some delta R, can I take it as R plus delta R whole square?
Yes, sir.
Right? So from this R square, I'll take it common. It will be R square into R 1 plus delta R by R the whole square.
Yes, sir.
So Gm by R square is
G.
G.
divided by 1 plus delta R by R the whole square is
Yes.
your G dash.
Yes, sir.
So G dash equal to G into 1 plus delta R by R the whole power minus 2. Binomial expansions, removing your higher numbers. 1 minus 2 delta R divided by R. This is your G dash. He is asking your percentage change, no?
Yes.
So G dash is equal to G minus G into 2 delta R by G dash minus G divided by G is minus 2 delta R by R.
Yes, sir.
So G dash minus G is delta G by original value. Change in value by original value will give you a percentage change, no?
Okay.
Yes, sir.
So this is given how much?
1 point.
3%. Did we do this question?
No, sir.
Do it.
The second option. The first option says.
What's your formula?
The G is equals to
Dash
G dash.
Sir, I got fourth option.
Why are you getting all different options?
So it's the first option.
Oh, sorry, sir. First option.
So multiply mg is equal to mg minus m omega square r. He said, what should be the angular speed with which the Earth have to rotate on itself as the person on the equator would weigh 3/5 as much as the present,
Yes, sir.
right? So 3/5 means 2/5. So the answer will be 2g under root 2g by 5/1, no?
Yes, sir.
W dash is equal to W minus
M
m omega square r. So this is how much? 3/5 of the present
times
value.
W
So minus 2w by 5 is equal to minus m omega square. Minus minus gets cancelled. This is 2g by 5 is equal to omega square r.
2G by 5 R the whole cube.
This question.
Is it 15 meters?
How much?
15 meters.
1/5. Huh?
Yes, sir.
Yes, sir.
Okay, everybody else got the same one.
Yes, yes, sir. Even I got 15 meters.
Um, 9.8, 4, 5, 15. Yeah. So we use under root G1 H1 should be equal to under root 2G2 H2. From that, G1 H1 should be H2.
And
H2 is equal to G1 H1 divided by G.
G2. Just 5 into.
96 into 3 divided by
So it will be 9.8 into 3 divided by
9.8.
divided by 1.9. 1 is 5
5 times. Now you are feeling your gravitational chapter easy.
Yes, sir.
This one.
So it's fourth option.
Sir, I am getting 2 mgr by 3.
I suppose this should be because obviously get this only. No? How can you get a whole number? What is your potential energy on the surface?
Minus G mm by R.
One. What is your potential energy when you take it to the distance of 2r above?
Minus G
Yeah.
m
M by r plus h.
3r. No?
Yes, sir.
Yes, sir.
He is asking the increase in potential energy. So find out delta P. No?
Oh. Yes, sir.
Two by 3 GMM by R you will get, right?
Yes, sir.
Into R divided by R. So 2 by 3 mgr you will get. Understand? This one. What? Conservation of energy, Amma.
Yes.
This body initially to get rest 0. When it comes here, what will be your? So what is your potential here?
Minus G
Divided by 3r, no?
Yes, sir.
Yes.
Right? I'm taking this potential because I'll take kinetic energy per unit mass, right? Plus 0 is equal to minus gm divided by r plus v square by 2, isn't it?
Yes, sir. The answer 4 under root of 4G m by 3R.
Good. So v square by 2 is equal to gm by r. I'll take common. This will be 1 minus 1 by 3, right?
Yes, so it's 2 by 3.
3 is equal to
Under root of 4 GM
3
by
and
3R.
3
3. This is your velocity. Now you are finding it easy. Conservation of energy.
Yes, sir.
I think we have done this. I'm reading the question. Tell me if we have done it or not. If an object is projected vertically upwards with a speed equal to half the escape speed of Earth, then the maximum height attained by it is.
So we haven't done it, but it's can do it. So we haven't done this. So R
No.
is R by 3, not R.
Huh. Again, take your condition of
Energies.
energies.
Yes, sir.
Same way. Okay. Take down your homework questions. Mohit, you sent me advanced material, this one only.
Yes, sir.
Have you completed exercise 1?
Almost done, sir.
Yes. Almost.
Exercise 1, 127. One 131, 2, 134, 137, 141, 143, 148, 150,
150, sir.
150. 157, 159, 166, 173. We have just done it, no?
Yes, sir.
Exercise 2, second question, fourth question, sixth question, 9, 12, 15th one we have done, right? Annular disc.
Yes, sir.
19, 27 and 28. Exercise 3, third question. Excuse me. Eleventh question.
Exercise 3, no, sir.
11, 12, 15, 31 to 33. Okay?
Yes.
So that's your homework for today and tomorrow. So how many I gave total?
Sir, around 25 or something.
28 are there.
28, sir.
Huh?
28.
28, yeah. So try to solve as many as today and some tomorrow. Okay? You have to show me that I've completed these questions.
Yes, sir.
Okay, sir.
Try to do use your conservation of energies, conservation. See, Kepler, whenever question comes in your planets revolving, satellites revolving, please remember conservation of angular momentum, conservation of energy. Clear?
Yes, sir.
So whenever a body is given, cavities are given, because of the total mass you will find, because of the small mass you will find, from that dish you will remove it. Okay, I'll
Yes,
see
sir.
you tomorrow.
Thank you, sir.
Thank you.
Thank you, sir.